Good morning to one and all for the today's morning session in metal cutting and forming. So today in module 4 we'll be discussing about drawing. Before going to drawing, first of all we'll be discussing about defects in rolling. Okay. After completion of this, we'll be going with drawing. Okay. So defects in rolled products. What is defects in rolled products? Will be defects due to roll gap. You all can see here the waviness and edge defect and this cracking and elongating, light reduction, heavy reduction. These are the defects in rolling. Okay. So defects due to roll gap. The roll gap is not parallel. It leads to non-uniform rolled product. Due to the tendency of the rolls to bend elastically under roll pressures, they may lead to crown shaped defect on the product. This is termed as waviness defect. So first of all, we'll be discussing about waviness. What is waviness defect? If due to the tendency of the rolls to the bend elastically under roll pressures, they may lead to crown shaped. You all can see the crown shaped here. This portion is a crown shaped. Okay. It may lead to a crown shaped defect on the product. This is termed as waviness defect or edge buckle. Okay. Edge buckle. You all can see this edge and center. Okay. Next one, defects due to inhomogeneities in deformation. Okay. The result in the defective shape and flatness of the rolled products, and which in turn develop various types of cracks. Next we will be discussing about cracking. How cracking occurs. The result in which the defective shape and flatness of the rolled products, and which in turn develop the various types of cracks. When the metal is rolled, it has the tendency to expand laterally, which in turn is opposed by transverse friction forces. Okay. Due to the friction hill effect, the sheet undergoes more deformation. What happens? Due to the friction hill effect, the sheet undergoes more deformation in the center. We have shown in this here. Okay, more deformation in the center than in edges. Okay, resulting in slight rounding at the ends. Because there is continuity between the edges and the center, the edges are strained in tension more than the center, resulting in edge cracking. So it is known as edge cracking. Okay. Under severe condition, the strain distribution can also result in a center split termed as alligating. This is in this way. This alligating defect. Okay. Defects due to defective ingots. Okay. Internal defects like fissures in rolled products can occur due to incomplete welding of pipe and blowholes in the original ingot. Blowholes in the original ingot. Bad melting, low temperature pouring and uncontrolled solidification practices can cause inclusion defects, perlite banding in steel products made from ingots. These defects can be minimized by use of good quality ingots. Okay, these are the defects. Okay, next we will be discussing about the defects in rolled products. Those are the defects may arise due to surface irregularities. The ingot or the raw material may be having irregularities due to scaling, which get trapped in the metal and remain inside the metal surface as laps. This needs to be removed by grinding. There will be some amount of metal loss. Okay, So if the defect is deep and the severe, the product may get rejected. Okay. Next one, the non-metallic inclusions. The inclusions may result from oxides or nitrides or silicates, etc., especially in steels. Okay, these are present in molten metal during the preparation. If less in volume may cause the small cracks in the metal, and if the more in volume will result in severe cracks called crocodile cracks, separating the product into two holes. Did you all got? If small cracks occurs in the metal, what happens? Less volume may cause small cracks in the metal, and if more volume will result in severe cracks. Those are known as crocodile cracks, which separates the product into two holes. Okay. Internal pores. There may be pores in the product due to the presence of gases like hydrogen, oxygen, nitrogen, etc. If too much gases are present, leads to elongation of the pores and the product may become weaker. Sometimes separation may take place resulting in cracks. Next one will be barrel. Due to the friction at the edges of the products, the barrel action takes place. Surface in contact experience severe friction as compared to center of the work. Hence, with the heavy reduction in the work, center tends to expand laterally more than outer surfaces in contact with the dies, and the produces barreled edges. So barreled edges, you all can see this is a barreling. Product has been done barreling. And next one will be non-uniform deformation. So non-uniform deformation, when the rolling conditions are such that only surface of the workpiece is deformed, the cross section of the slab is deformed into shape as shown. You can see the figure. Okay, here the deformation occurs in this way. Okay, the middle portion is less deformed as compared to the outer surface. Okay, this may be due to variation in temperature in the metal, surface temperature being more than the inside temperature of the slab. Next one will be alligator. Alligator, as we have discussed in the previous slide, alligator cracks. If there is any metallurgical weakness, okay, if there is any metallurgical weakness in the metal due to the presence of inclusions along the center line of the slab, fracture will occur. This results in separation of the layer, giving rise to opening of the slab, which looks like alligator mouth in opening position. Alligator mouth in the sense crocodile mouth. You all can see this shape, how it has opened. You all can see the opening of the mouth. It looks like similar to the mouth of the alligator or the crocodile, we can say. Okay, and other defects in rolling: hydrogen cracks, non-metallic inclusion, defects operational, that is waviness and edge cracking, we have discussed in the previous slide. Next we'll be discussing about the requirement of the drawing process. So why we need drawing? Okay, the material should have sufficient ductility so that it can sustain tensile force. For this we need drawing process. The material should possess high tensile stress. For this also we need. The rod or the wire should be properly cleaned and dust or scale free before drawing. It should be properly lubricated to reduce friction associated with operation. So working process of the drawing working process, all drawing process works on the same principle. Its working can be summarized as follows. First one, will be hot rolled, second one will be pickling, descaling, in that cleaning operation is occurred, sullying, lemming, etc. in that lubrication occurs, and next one will be drawing operation. These are the layers one above the other. Next, drawing. First of all, we'll discuss what is drawing. Drawing is a metalworking operation and generally refers to the process of producing of wires and rods and tubes. Okay. The drawing is cold working process, and in the process deformation takes place by the application of tensile forces. It involves pulling the material to be drawn through a hole in a hard steel or carbide block termed die, and reduce the diameter of the material. Okay. The tensile forces induce indirect compressive stresses at the die surface and cause plastic flow of the metal. The process of reducing the diameter of material by successive drawing operation is termed as bar, rod or wire drawing. In that we'll be discussing next. Drawing process can be divided into following three types. First one is rod drawing or rod drawing equipment. You all can see this figure, and wire drawing. Next one will be tube drawing. So first of all, we'll be discussing about drawing equipment, that is rod drawing or rod drawing equipment. You all can see this is a chain drive. Below the carriage, this portion is a carriage. Below that carriage we have the chain drive, and before seeing the chain drive, where the carriage is located, you all can see that is a draw bench. Okay, this portion is a draw bench, and below that there is a chain drive. Okay, and you all can see the draw head direction is shown here. Okay, and these are the jaws. This portion is a jaw. Okay, this portion is a where this is the workpiece, which is the jaws are holding this workpiece. This portion, this is the workpiece which is holded, or which is the jaws are holding first, and this is the second jaw. Above and below the jaw or the workpiece, there are jaws which holds the workpiece properly. And over here there is a die and die block. Okay, so in this equipment, the rod drawing process involves cleaning the material, pointing or tagging the rod and drawing, and these are the points. So what is cleaning before drawing? For steel rods that are previously hot rolled or extruded, surface cleaning is required. Okay, we are discussing about rod drawing here. In that, first will be cleaning before drawing. For steel rods that are previously hot rolled or extruded, surface cleaning is required here. For this, the material is immersed in dilute hot solution around 75 degrees Celsius of hydrochloric or sulfuric acid. Okay, this is termed as acid pickling. Previous we have seen in here pickling process. Okay, this the similar thing we are discussing here. Okay, this is termed as acid pickling. This removes any scale, oil, grease, etc. present on the material surface. It is then washed with water and dipped in an emulsion of slaked lime and water. This neutralizes the acid, and excess lime dries on the material surface and forms a base to absorb the mineral oil or the grease, whichever it may be the lubricant. Soap can be also used as a lubricant, but results in dull surface of the finished products. Okay, next one we will be discussing in the rod drawing, pointing or tagging the rod and drawing. Since the rod is drawn in a straight length, the operation carried out on a draw bench, which must be long enough to accommodate the length of the rod required. A draw bench consists of a die held rigidly in a steel frame and a dog which grips the end of the rod and pull it through the die. Okay, these are the things. Next we will be discussing about wire drawing. Okay, this is wire drawing. So you all can see the wire drawing. At the left end it is a coil and at the right end it is a bull block, and this is the wire which is rounded. Wire drawing starts with hot rolled wire rod. Similar to the rod drawing, the rod is first cleaned by pickling and washed. That process we have seen in the previous slide. It is then coated with a lime or plated with thin layer of copper or tin. The lime neutralizes any acid and serves as an absorber and carrier of the lubricant during dry drawing. The lubricant may either be grease or soap powder. For wet drawing operation, the die itself is immersed in the lubricant. Okay, the schematic diagram has been shown here. This is the die and this is the wire which is running, and this is the bull block and the coil. Okay, the wire is to be drawn is held in a loose coil and to start, okay, and to start with the end of the rod is tagged inserted through the die and then finally locked in the gripper jaws of the bull block. Here we are going to lock here bull block. Okay, when the bull block rotates at high speed, it pulls the wire through the die, thereby reducing its section and winds up the drawn wire. You all can see it is reducing the wire by rotating this bull block. When this bull block rotates, the wire is reduced. Next one we are going to discuss continuous drawing. In continuous drawing, you all can see the initial wire stock in a coil form, and next one, this is the lubrication box which supplies lubrication, and this is the draw die, and you all can see the one more wheel. So sequentially it is situated, that wheels are situated, so the wire will be rotating as with the help of these wheels. Okay, so we also see this capstan drum or holes in a multiple loops of wires. Continuous drawing of the wire, this is. Okay, for drawing of fine wires, a large number of draw blocks are used. Here, with the wire passing through a number of dies until it reduces to a final size in one continuous operation. Okay, for fine wires, reduction per pass of 15 to 25% are used, while for coarse wires the reduction per pass may be 20 to 50%. In drawing operation, depending upon the metal and the reductions, intermediate anneals may be required to restore ductility. Okay, these are the things with continuous drawing. Okay, next we will be discussing about tube drawing. So in tube drawing, you all can see tube sinking or drawing without mandrel, first one, and second one, tube drawing with a fixed mandrel. Okay, this is a with fixed mandrel. And third one is this is without mandrel with die, and fourth one is tube drawing with floating mandrel. Okay, these are the things. So we'll be discussing one after the other. First of all, we'll be discussing about tube sinking. Okay, tube sinking. Tubes having higher wall thickness compared to the diameter can be drawn without a mandrel. This method is generally termed as tube sinking. Okay, by this method diameter reduction is up to 35% can be obtained in a steel tubes. One end of the tube is switched so that can be inserted through the die held by the pulling jaw and then drawn similar to a rod. The process requires similar surface cleaning and lubrication system for smooth drawing operation. Okay, and this process is very simple as there is no mandrel. Okay, as there is no mandrel, the process is very simple. Frictional work is only with the die and the tube. With the die and the tube. Here you all can see this is the tube and this is the die. Hence requires less power. Okay, higher reductions are possible, requires minimum lubrication over here. Okay, and next we'll be discussing about tube drawing with fixed mandrel. In this method you all can see a short mandrel or a plug is used to perform the drawing operation. The diameter of the mandrel is equal to the inner diameter of the tube drawn. You all can see the diameter of the mandrel is similar to the inner diameter of the tube being drawn. The mandrel is held in a position at the die land using a tie rod. Okay, in turn the tie rod is connected to a fixed rigid support at opposite end of the draw bench. Okay, in operation initially the end at the pulling side is tacked and inserted through the die. It is then gripped by the dog in the draw bench. The mandrel is inserted through the tube and its back end is anchored to its support. Okay, the tube is drawn through the annulus between the die and the mandrel. The gap between the mandrel and the die surface decides the diameter to be drawn. Okay, these are the things with fixed mandrel. Next we'll be discussing about tube drawing with a floating mandrel. Okay, tube drawing with a floating mandrel. When drawing with fixed mandrel, the tube diameter that can be drawn is limited due to various reasons. Even if a small diameter mandrel is used, it will be too weak due to low section size. Also, the length of the tube that can be drawn is limited by the length of the mandrel rod. This difficulty can be overcome by drawing the tubes with a floating mandrel. You are understanding why we are using floating mandrel. The length of the tube that can be drawn is limited by the length of the mandrel rod. So in floating mandrel these difficulties can be overcome, or we can say this difficulty is resolved. In this mandrel of a shorter length with the dimensions of internal diameter is located at the die entrance as shown in figure. Okay, as the tube is drawn, the mandrel floats inside the tube and forms a suitable gap for tube drawing. With this, practically there is no limit on the length of the tube drawn. The contour of the mandrel is such that it adjusts adjusts itself to the correct position while drawing in its counter design to match with the internal dimension of the drawing die. Okay, these are the things. Next we'll be discussing with the last one, that is rod drawing, or it is drawing with the moving mandrel. Okay, moving mandrel. In this method, the long mandrel is used to draw the tube. The length of the mandrel is longer than the tube to be drawn. Generally, the mandrel is made of heat treated alloy and steel having good wear resistance. Okay, these are the things. Next we'll be discussing last slide, that is applications. This process is used for making wire of copper, aluminium, etc., which are used in electrical industries. Second one, paper clip, helical spring, etc., are wire drawing product. Small diameter rods and tubes are drawing the product. Next one, it is used to produce large length of small cross section. And last one, this is also about basic principle of drawing process, types like wire drawing, rod and tube drawing. If you have any query regarding this article, ask by commenting. If you like this article, with this we wind up for the today's class. If you have any doubts, you can call me. Thank you for the today's session.